Okay, Chapter 2 Probability Theory. We start with a sample space. Okay, when we want to compute or calculate a probability of an event, we must know what is the sample space. The simplest example to make you understand better about what is sample space is example 2.1. We always use the coins or the dice. Dice is like you may get 1, 2, 3, 4, 5, or 6. So as examples to make you understand the concept of probability easier. So okay, example 2.1 we use a coin as examples. When you toss a coin, you may get head or tails. These two outcomes. So now if I ask you what is the probability of getting a head, then the answer is very straightforward. It's 1 over 2. But what is 2? 2 is the sample space. Okay, this is a sample space. Sample space we have got 2. When we say the probability of head or the probability of tail is they are equal, so that's why the value is 1 over 2 is or half. Okay, so now we go to and this example 2.2. So we have a case of we use dice. So dice, what is the sample space for dice? Is 1, 2, 3, 4, 5, 6. So this example will show you we can define the sample space in different manners. So for the case of dice, if I say what is the sample space for you to get a value of dice, then the sample space must be 1, 2, 3, 4, 5, 6. There are 6 altogether. There are 6 elements. But we also can define in another way, depends on your interest of your work or your experiments. We can say the sample space can be divided into two types. You can may get even numbers or odd numbers. Even is 2, you get 2, 4, or 6. Odd is you get 1, 3, or 5. Okay, so now we go to more complicated sample space. So you say we have 3 traffic light, and we select them randomly because out there are many. We can select 3. So we will classify the traffic light into 2 status. One is defective, one is non-defective. So the traffic light, you go to check one by one. There are 3. It may be defective, that are labeled as D, non-defective labeled as N. So what are the total sample space? So for the beginners, okay, it's quite difficult for you to figure out. So that's why now we use the concept of probability tree. So this is the probability tree. So we start with the first level. So the first traffic light can be D, can be N. For the traffic light, first traffic D, second traffic light, it can branch out into 2 D, N. And for the first D, okay, this also can be branched out into 2 D and N. So what is a sample size? Sample space, sorry. Sample space, it can be D, 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 N, D, N, D, D, N, N, and so on until the last one is N, N, N. So when you list down, then you get the sample space. Of course, this is very fundamental method for you to understand what is probability tree. But say for example, if so now is only 3 traffic light, you still can draw it on a piece of papers. But how about 30? How about 50 traffic light? So that's why later I will teach you a more easier way or a more efficient way for you to draw the traffic lights, for you to calculate the sample space. Okay, so event is a subset of sample space. We refer to the first examples. So what is a sample space for you to get for sample for when you toss a dice? So when you toss a coin, it can be head or tail. So there are 2. So the probability for you to getting a head is an event. So so we only can find probability for an event because when you toss, before you got the outcome, you don't know whether it's a head or whether it's a tail. So that's why we call it an event. Okay. Now you refer to example 2.4. You refer to example 2.2. List out the event A that the number that show on the top face of dice is greater than 3. So we know that greater than 3. Greater than 3 means that 3 is not included. It's 4, 5, or 6. So A is a definition of events. Again, another examples. Okay, refer to the example of traffic light. You say at least 2 traffic light are defective. So it means that we got 2D. So that's why now you see that we label as event B. Got at least 2 traffic light are defective. DDD, DDN, DND, and NDD. Okay, the sequence of D and N play different role. They are not the same. Like D and D, D D N, even though they have 2D, but they are not the same case. They are two different cases. Okay, complements. Okay, whatever you included, whatever you are not included, will become the complement of the event. So just now we say at least event B, at least two traffic light are defective. So means that for the rest are not included in the event A, we call it a complement of event A. So that's why okay, we list it down. So we have D and N, NDN, and ND, and N, which is less than two defective traffic lights. Okay, subsets. Case A and B. So means that they have commons. They have common elements. So example 2.7. Let C be the event that a student selected at random is from the department mathematics. C is student from department mathematics. D is a student is a female student. So what is C and D? C and D means that we want to find those from department mathematics, and at the same time they are females. So this is what we call the intersections of two events. Okay, so now we look at another examples. Okay, we say A be the event that number that show on the top face of a dice is not greater than 4. It's not greater than 4 means that okay 1, 2, 3, 4, and B is the odd numbers is 1, 3, 5. So what is the event A not greater than 4 and E is odd numbers? So if you refer to A and B, so they have only two common element, which is 1 and 3. So mean A intercept B is 1 and 3. Okay, mutually exclusive. So it's a special case for intersections. When they don't have any common elements, then we say that they are mutually exclusive. So we will say A and B is equal to none. So if you refer to example 2.9, you compare A and C, they have no common elements, okay, together. That's why A and C is equal to nothing. So some people they read it as 0. No, this is not 0. This is null, N-U-L-L, null. So means that there is nothing. Okay, unions is everything's included. So example 2 tenths. Okay, we refer to 2.9, A or C. So when you mix up element for even A and element for even C, we are not counting how many elements they are the same. We just put them together. So you will get A union of two event A and B. So if you refer to example 2.11, okay, we have event E and event F. Event E is the number between 4 to 8, 5, 6, 7. Okay. Event F is greater uh, than 5. So that's why when we combine them two, you will get the event, the value is greater than 4. Means that we group them, we merge them into one case. Okay, so tutorial 2.1, I want you to try first, then we will discuss later.